Well, hello everyone. Thought it'd be a good day to do Codeforces round 741. 3 minutes till the start. Pretty excited. Let's see. Yeah, I ended the last one like 5 minutes before the end of the contest because I didn't really feel like hacking up a C solution because I don't know. It's been a while since I've actually run something in C, and I didn't want to figure out how to do I/O in 10 minutes on stream. But right after, I was like, actually, it shouldn't be that hard. But unfortunately, it took me 11 minutes. I didn't have time to submit, but I just changed everything from like my Pythonisms to my C-isms, and it sort of just works. Yeah, so the original one looks like this, and as you can see, it's like basically identical. And it actually just works very fast. So it was large. Yeah. Okay, so it works fast enough because there's like a 6-second limit for this problem. So on my machine, it's like 1 Mississippi, 2 Mississippi. I guess I can just use time instead of like counting it out. Oh, right. It's waiting for me to input. Oh, I guess it's hard to time when there's like I/O. So I don't know how long that took me to type, but it looks like. Oh yeah, it looks like it was really fast, like 2 seconds. But unfortunately, I wasn't able to submit it, so I lost some rating points. Yeah, I should probably switch to using C principally, because it seems like this has happened a few times. But yeah, I opened up someone else's C submission here, so if we feel like we need to switch to C real quick, I'll just like copy their I/O. It actually looks very nice how I/O works, like the C in thing. On my solution, I used a scanf, which I don't think would be possible for most problems. So this problem only has 2 numbers as input, so it works pretty well. Oh, hey, Scruffy Wars. C, yeah, C sucks. Python is the way, but somehow it's actually slow. I thought it was a meme, but I guess it actually, so all I did is like rewrite my Python solution like line for line in C where I needed to change the syntax, and I think the Python solution would have taken like an hour to run or something, but the C one takes about 2 seconds. Oh yeah, I guess we'll use C++ if we are forced to in this contest. I've got I'll just copy this person's solution, but change the algorithm. I really like this notation for input and output, so maybe it's actually just better than Python. Just 1 more minute. Yeah, I've been uploading these to YouTube recently, and no one's been watching them. But the last one, 50 people watched. So I don't know why the change. Algorithms, man. Right. This one's written by Wind Eagle. This person's only orange? Looks like there'll be 20,000 people in the contest. I don't understand why they close registration early. Like, why does it matter if people register in the last 30 seconds? Maybe they're worried that there'll be some like technical issue and they won't have time to recover if like the 64,000th person joins. Has anyone been following the Cinquefeld's Cup? I think Fabiano can pull it out. I did some math. I think he's like actually surprisingly not that unlikely to win. I thought he'd be close to 0, but I'd say he's like maybe 15% to still win. If you do all the math. Okay, here we go. Okay, so the miracle and the sleeper. So I'm given 2 integers, L and R, and I want to find the largest possible value of A mod B over pairs AB between R and L. Oh yeah, so oh okay. Wait, so B has to be less than A. It's sort of an interesting problem. So I kind of feel like I can just always take B to be. No, I want B to be as large as. Oh yeah, B has to be smaller than A though. So I can't just have B R and A B R minus 1. Okay, and A can equal B. Okay. Hmm. Wait, this doesn't actually seem a Dream Theater reference. I haven't actually watched Dream Theater. What's it about? Okay, so this is two things. I get R and L in that order. Or I guess L and R. So I don't actually see this right away. Maybe the output will help us understand. Okay, so this one is not interesting. It has to be, they have to be equal, and we're doomed. This one, they're just off by one. So yeah, there's only one output for which one is optimal. I'm getting a call. I never answer my calls because they're always spam. So whatever I choose B to be is an upper bound on what the answer could be, because I mod by B. So I kind of want to choose like the largest possible B, but then A will, oh, okay, so I think the right answer will be like the midpoint. Like I'll let A be the largest value, and then I'll let B be that over 2 rounded down, or -1 rounded down. Yeah, I think that'll be right. Okay, so okay, and then sometimes that'll be larger than L, and then I'll just let B be L. And no, that can't be right. Huh. Sort of a tricky problem. So if I let no, I think that's right. Yeah, so B will be R over 2 rounded down. But if that's not possible, or not rounded down, I want it to be rounded up. Yeah. And then if that's not possible, I'll just go up to L, and then A will, like, the maximum will be like R minus L. Yeah, I guess R minus L is always achievable. Okay, so okay, so my lower one will be the maximum of L and R divided by 2, but I always want to round up. So wait, if I add 1, then it'll round up odd numbers, but not even numbers. So I add 2, and then I'll round up odd and even numbers. Yeah. And then I guess my answer, or I'll just print my larger one mod whatever I chose the lower one to be. Oh, I need to change directories. Let's see if that's right. Okay, so it looks quite wrong. Oh, I need parentheses. Forgot my PEMDAs. Okay, 0, 1, 12. Okay, I think this is right, though maybe I should do a little bit of thinking. Oh, I forgot to pre-open stuff. Where am I? Development, competitions, Codeforces, R741A. I'm just gonna submit. Okay, this is an unusually hard first problem. 6 minutes. Let's see. Okay, 1700 ahead. Okay, so scenes from a memory. A progressive metal band? Oh, cool. I'll have to listen to it after this stream. Or maybe I should figure out how to like play music on stream and just play it on stream. But I guess I could get like sued or something if I do that, right? I don't know if that's an issue. Okay, so during the hypnosis session, is this also a reference? Okay, Nicholas suddenly remembered a positive integer n, which doesn't contain zeros in decimal notation. So then when he returns home, he's curious what is the maximum number of digits that can be removed from the number so that the number becomes not prime. Okay, for some numbers, doing so is impossible. Okay, yeah, 53, that's not possible. However, they're only going to give us ones where it is possible. Okay. Note that you cannot remove all the digits from the number. Okay. A prime number is a number that has no divisors except 1 and itself. Yeah, so they're just defining prime. Okay. So how large are these numbers they're going to give us? Oh, okay. Oh, okay. So these can be quite large numbers, up to 50-digit numbers. I wonder if there's some trick here with like divisibility by 3. I think there should be a trick for large numbers, because of course if so there's no zeros, that might be. Oh, I think the reason they specified this is so we can't like remove the first digit and then have a leading 0, so you can't like remove 2 digits essentially. I think that's why they specified this. Okay, but so all the digits are either 0, 1, 2, or 3 mod 3. And if there's enough digits, then it'll always be the case that we can remove 1 to make it divisible by 3. Yeah, if there's one of each, if there's like a type 0, 1, 2, then the number of course has something mod. Yeah. Okay, so these numbers are quite large, and okay, and then if they're small, okay, so they guarantee it's always going to be possible. K could be as small as 1. And what do we print out? Do we print out the answer or the digit we remove? Oh, okay. Wait, I'm confused. What are we supposed to output? Print 2 numbers in 2 lines, the number of digits that we have left. And then, wait, so in this one you have to delete all the way to 6? Is that? That can't be true. I'm confused. Why don't you just delete this 1 and then get a number that's divisible by 2? For every... Oh, so... Oh, so we don't delete... Do we delete all the numbers at once? So, like, in this number, you can either delete all the 1s, all the 2s, or all the 6s, but you don't just choose 1, 1 to delete? Oh, okay. I guess that changes things then. Oh, we want to delete as many as possible, not as few as possible. Oh, thanks, Cassinigrad. Are you doing this one too? Okay. So actually, okay, this might make things easier then. So, we can do like a. Okay, so if a single digit is composite, we can remove everything but that one digit. So the composite digits are 4, 6, 8, 9. So if it contains any of those, we can just delete them and we're done. 4, 6, 8, 9. And then if it contains any matching digits besides ones. Oh, if it contains a 1. Yeah, 1 is, I guess, composite for our purposes. So, let's see. Okay, so we scan in the whole line. You know, I think I want to read it in as a string. Yeah, just read it in. Okay, so what's my algorithm? If it contains 1, 4, 6, 8, 9, print that. Okay. If it contains a pair of 2s, 3s, 5s, 7s. So if it contains 2 of any type of prime, then we can just delete down to those 2 and print that out, and they'll be divisible by 11. So print those, because we can print out any solution that is the smallest possible. Okay. And then there's just the situation. Okay, well, actually, I guess I'll just say if it contains a non-leading 2, print that with leading digit. Okay, so now I know it doesn't contain any of these numbers or a non-leading 2. So obviously it has a pair of 2s as a non-leading 2, so I'll delete that. Okay. What else? Okay, so if it contains, so 57 and 75 are both not prime. So okay, so if it contains a 5 and a 7, print those. Okay, and then if it contains a 35, print that. Okay, so is that, I mean, this might be exhaustive. I think we might be able to just type this up and be done. So what numbers are left? There's numbers that contain none of these. Oh, 25 is left. Yeah. So 25 and 27. Okay. So if 1 inline print 1, print 1, and then I guess I just keep going. So 1, 2, 3, 4, 5. So now 4, and now 6, Now 8. Wait. And last 9. Oh, wait, what am I doing? Still going to once. Okay, so this should be 9. Okay, so this is all the 1-digit solutions. So that just leaves things that, now at this point we only contain 2, 3, 5, 7. Okay. So if 2n, so I noticed this algorithm is like sort of linear, because all we do is like keep calling these ins a bounded number of times. It'll be fast enough. So if 2 is in the rest of it, not the leading bit, then what do? The answer is 2, and I'll just print the leading digit plus 2. Okay, so if should I say count, if line dot count 3. Oh, do I need to put all these in parentheses? I think I might. Probably should have recorded a macro for this. There's a lot of implementation here. Okay, so if it contains 3 more than once, then I'll just print 2, 3. And then same thing for 5. Oh. So replace that with 5. Replace it with 7. Okay. Okay, so now we're down to numbers that only contain 2, 3, 5, and 7, and don't contain more than 1, 3, 5, or 7. Maybe I'll also stipulate that they don't have more than 1, 2. So just do it again. So if there, I should yank this. So if it contains 2 more than once, then I'll just print 22. Okay. So now we only have, oh, I need a ton of continues here, so we only print one thing. Okay, so then so now we have a number that only contains 2, 3, 5, and 7, and contains no non-leading 2s. So and has none of 3, 5. It has none of 2, 3, 5, or 7 more than once. Okay, so that's not very many numbers. Okay. So let's do the rest of the cases. So if, I guess I should say line dot find 5, or is it index of? Let me check some Python things. So is find? No. Oh. Okay, so find works. Okay, and it returns the first index. Okay. So, well, I'll just say if 5 and 7 are in this line. So if 5 in line and 7 in line, then I'll just, and then let's say if line.find 5. You know what? This is really dumb, but there's... I think I should just iterate through... Yeah, I should like not be coding this. This is like insane. I should just like iterate through the numbers 1 to 100 and check if they're in, and just print out the first one I find. Yeah, let's do it that way instead. So for I in range 1, 100, I think, or I don't know. I'll even be safe. I'll just keep going. Why not? I think after 2 digits, you're guaranteed to find one. So if I'll just make a function for this. So I'll call it sub number I string. So so there's like some argument you can give, right? And then it'll like skip the first one. Okay, yeah. So, and if I do 0, okay. So at equals 0. I'll convert I to a string. I equals stir I. And then let's just say for C in I, if s dot find C starting at where we're at, if we find it, if it's greater than 0, then at should equal what we found, s dot find C at, and then if we don't find it, just return false. And if we find everything, we'll return true. Okay, and then we'll have an isPrime function. So for I and we can just do it super naively. So for I in range, well, I guess, yeah, I'll just go up to, so for j in range I, if I is divisible by j, then I'll return false. Otherwise, I'll return true. Okay. And yeah, this is like as naive as possible, but I'm pretty sure we'll only go up to 2-digit numbers, so it's fine. And then I'll just say if not is prime I, and it is a subnumber I line, then I will print out what I found. So, oh, I guess I need to print out the number of digits. So what could be more efficient than that? And then I'll print out I, and then I can break. And I'll just comment this out with continue just in case I decide I want it later. Just delete that. I think this is a little more sane than actually trying to understand what the numbers could look like. Oh, I want to start at 1. No, I want to start at 2. This is not continuing. Oh wait, I read in 2 numbers. I need to actually read in the second number. Still printing out a lot. Why is it printing out so much? Oh, I don't want to print the line, of course. Okay. 233. Okay, so it's... Well, why would it find 33 and not 27? Oh, am I not reading in T? No, I'm reading in T. Oh, I think... Oh, I need to let at equal this plus 1. So, yeah, otherwise it'll find 33 when it shouldn't. Okay. So, wait, this isn't working either. It's not... Wait, what's it doing? So, first number is 237, and I print out 1, 2? I should test subnum. Let's just see if 5 is a subnumber of 55. Let's see if 52 is a subnumber of 552. Let's see if it's a... False. Oh, that's... Okay, so that's wrong. Wait, why is that not working? So I turn I into a string, and then I iterate over the characters in it, and then I see if I can find them. Wait, why is that wrong? I guess I should print out more stuff. Okay, so it's correctly iterating through the digits, but it's not finding them in here. Why is S is 55, right? Why is that not working? Maybe find is not doing what I think it's doing. 55.find50. Oh. 0. Oh, I need greater than or equal to, not greater than. Oops. And if it doesn't exist, if it doesn't find it, it returns negative 1. Right, but it can return 0, of course. Oops. Okay, now true, false. Okay. And I guess I'll just paste in the input. What? It's printing out a lot of stuff. Why is it printing out so much stuff? Oh, right, because there's all these print statements that I should get rid of. Okay, let's see if that works. It's a lot of input data, actually. So I think it's 227, 14. Oh, it should start at 1. Wait, why is it? Yeah, why is it not returning? Oh, okay. So, wait, I'm confused. So 14, 220. I should. Okay. What do we got? We got a 227, 1, 4. Okay. So it's incorrect on some of them. Is it? Wait, is it actually printing out enough stuff? What is the length of this? 1, 2, 3, 4, 5, 6, 7. 14 things. 1, 2, 3. Yeah, it should print out 14 things. Oh yeah, Control D might be optimal. Yeah, that's a good catch, Scruffy. Wait, what's wrong here now? So I start at 1, which is what I want. Does it think 1 is prime? Oh, yeah, my algorithm for 1 is wrong. If I equals 1, return false. Okay, so now it goes 227, 1, 4, 1, 1, 235, 277, 1, 4, 1. Okay, yeah, and this one is fine. It could be either 1 or 6. And yeah, mine will always go for the first one. Let me just test it on some weirder ones, like what about 35? Okay, if it gets that one. I don't know. I guess there are no weird ones. They're all like the same. Okay, I think it should be correct at this point. And I think, yeah, I'm pretty glad I did it the way I did it. Maybe I'll just delete everything that comes after this. Okay. Looks like I didn't change anything. Yeah, submit. Yeah, it would have been pretty insane to complete that big if statement, but it would have worked, I guess. It's kind of weird to delete the maximum and not the minimum. I thought we would have to do all this like thinking about like how many digits were 0, 1, and 2 mod 3. Okay. Sorry. Imagine we kind of fell behind there. Yeah, we're like 1,000th here, now we're 2,000th. That was maybe not the fastest showing. But yeah, let's see what Rings is about. Frodo was caught by Saruman. Oh, I get that reference. Okay, he tore a pouch from Frodo's neck, shook out its contents. There was a pile of different rings, gold and silver. How am I to tell which is the one, the mage held? Throw them one by one into the cracks of... Okay, somewhere in a parallel Middle Earth, when Saruman caught Frodo, he only found N rings. And the ith ring was either gold or silver. For convenience, Saruman wrote down a binary string S of N characters where the ith character was 0 if the ith ring was gold, and 1 if it was silver. Saruman has a magic function F, which takes a binary string and returns a number obtained by converting the string into a binary number, and then converting the binary number into a decimal number. What? Returns the number obtained by converting the number into a binary number, then converting the binary number into a decimal number. Okay. Wait, I'm confused. What is it doing? It takes a string that's ones and zeros, then converts it into a binary number. So all it like first it removes the zeros, so we think of it as a number, and then it just tells you what the number is. Okay. I'm just confused why it had to convert it into a binary number first, but I guess it's because leading zeros exist or something. Okay, so Saruman, however, thinks that the order of the rings plays some important role. He wants to find 2 pairs of integers, L1, R1, L2, R2, such that, okay, so the first pair of numbers are between 1 and N, and this, okay, they're a certain distance apart. They're more than halfway apart. Okay, and the other ones have the same property that they're more than halfway apart. And they're 2 distinct pairs, but not totally distinct, just mostly distinct. Okay, and then we want to let T be the substring from L1 to R1 of S and W. So we've got T and W, and there's just a non-negative integer K such that f of T equals f of W times K. Okay. So, okay, then the one divides the other. Okay. Help Saruman solve this problem. Why are we on Saruman's side? I feel like we should be on Frodo's side in this one. Like, maybe just skip this one. We're on the side of evil here. Okay, so what is the size of things? So these are 10 to the 4th million things. And okay, and there's, oh, we need them to be large. Okay, we need them to be at least this large. Okay, so I guess my first observation is if you've got two strings and one ends with a 0 and the other one's just like the prefix, then it's just like the other one times 2, which is exactly what we're looking for, right? We're looking for a yeah. So it could be any integer k. So this is just a statement of divisibility. That f of w, the second one divides the first one. Okay. So what can we say if so we've got our string s1 up to sn. So if there is a 0 in s1 to sn over 2, then we can let our answer be so s1 maybe I need a -1. So if there's a 0 in here, let's say at I, then our answer can just be I to Sn and I plus 1 to Sn. And this number will just be half of this number. Yeah, it's just shifting by 2, which is the same as shifting by 1 bit, which is the same as multiplying by 2. So we'll have the divisibility property we want. And then there's the other case where there's just a whole lot of 1s. Okay. So suppose... So are we guaranteed that there's a solution? Oh, so something else I notice. Oh, they have to be distinct. Okay. But, oh, okay. So the pairs have to be distinct, but the numbers they represent don't necessarily have to be distinct. So this is what we can do if there's a 0 in the first half, but if there's a 0 in the second half, we also have an automatic solution. So if there is a 0 in Sn over 2 minus, I guess, plus 1? I gotta think more about rounding. What do you know about n? It could be, doesn't necessarily have to be like even or something, right? Okay. Oh, and we round down here. So the length of the string just has to be at least half rounded up. So I think we can actually... Yeah, I think we can just round down in both places, because here... no, I guess we need to... Yeah, we can round down here, and then the length of the smaller one will be like at most, at least half. Yeah. So we can round down here. That's fine. And then I think the other half we can also round down. Yeah, we should be able to round down there too. Oh, we might need to round up there actually. No, I think we can round down. So if there's a 0 at I and the rest of it, then our answer can be S1 up to Si. And it doesn't matter which is which in this case, actually, because they're just going to be the same number. Basically, all you do is truncate to 0. Okay, so this just leaves everything as 1. But maybe the problem statement says that's not the case. Wait, if everything is 1, is there even a solution? I don't know if there should be. Oh yeah. Okay, so then the numbers look like. So of course, if you have a string that's I ones, this equals 2 to the I, 2 to the I minus 1, yeah. If there's 1, then it's 1, and if there's, so in what situation does 2 to the I minus 1, or that's not where the minus 1 goes. In what situations does 2 to the I minus 1 divide 2 to the K minus 1? I feel like I know this. K equals 2i, for example. So 2 to the I minus 1 divides 4 to the I minus 1. Oh, yes, that is true, because this equals 2 to the I. Oh, thanks, Lunar got killed. Mm-hmm. Yeah, this equals this. Mm-hmm. Yeah, and if they're all 1s, this will always be a case, and we'll just let we'll just let the first number be the first half and the rest of the number be the rest. Oh, hey, Mayan casing 2K01. Yeah, I don't usually like to backtrack during the thing, because I don't know, sometimes I get in trouble because people copy my solution, and I try to make it a little harder. So no, I'm not going to go back. Yeah, Scruffy Walrus, you're right. This guy's a cheater. No, I shouldn't. I should say that. But what was the problem for A again? Oh yeah, it was like a relatively hard first problem, wasn't it? Yeah, but you let A be the largest number, and then you let B be half of the largest number, rounded up, or L if the max of those two. Hopefully that helps. Yeah, gotta go forward. Okay, so there's two cases, and or it's all 1s, or it contains at least 1 0, and then there's 2 cases for the 0s, depending on where the 0 is. Okay, so I'll just assume they give us an n. They always do. And then just read that in. Okay, so if I'll do the case where it's all 1s first. So if not 1, if not 0 in rings, then what do I just need to print out I just print out the numbers. Okay, and n was given, right? So then what should I print out? The first one should be the larger one, right? Oh, I guess another solution is I can just let the first string be the first half and the second string be the second half. I guess that's also a valid solution. I didn't even think about that, how k can just equal 1. Yeah, if they contain the same substring twice, then of course there's always a solution. So maybe I'll do it that way. So I'll just print, what are the numbers that I want to print? 1 to n over 2, and then n over 2 and then I guess n over 2 plus n over 2 plus 1. I'm just trying to write it in a general way that is true whether n is even or odd, which I think this way should be. Okay, then let's say if 0 is in the first half, I guess I can continue at this point. So if 0 is in rings up to n over 2, then I'll just find it at equals. Wait, do I need to add 1 here? Oh yeah, I can't add 1 there because wait, this, so yeah, if I add 1 then n is even, then of course that'll be n plus 1, which is not good. Wait, is this okay? Because this will be, I think I might need to round up here. Well, I mean, I can actually just start at 2. And then just go to the same thing, but longer. So plus 1. But then the length of this is going to be maybe too short. So, oh no, so the plus 1 is helping me. So when I subtract this, I get n over 2. Yeah, so this will work. Okay. So then if 0 is not in rings, no, 0, so that's if 0 is not in rings, and then if 0 is in the first half, I'll just find it. And then I will just print out those 4 numbers. So I'll start at where I found it. Maybe I'll let this be plus 1 just to index from it as the problem does. So I'll start at that, and then I'll go that far, minus 1. And then I'll start at plus 1 and go up to that plus that. And then the other case is if it's in the second half, but now I already know it's in the second half. So I'll just find it. I'll find the first 0. Wait, I'll just get rid of this if statement. I'm like exactly where I need to be. And then I'll start at 1, and then in the first one I'll go up to at minus 1, and that'll be long enough. And in the second one I'll start at 2, and I'll go to the same, no, I'll still start at 1, but I'll go all the way to at. And I think this should be right, modulo maybe some rounding issues. Yeah, so if n is even, this is like literally the first half. And And if it's literally the first half, I find a 0 there, I can just like go the length I need to go, which is this, and this can't be too large. And it's the right length, yeah. And if it's in the second half, then I end there. Okay, I think this should be good. Let's test it out. Two, 4, 3, 5. Yeah, so my solutions look nothing like theirs at all, so I guess I'll have to think about it for a second. Yeah, k is allowed to be 1, and the function f is sort of just like interpreting it as a number and truncating off leading zeros. So I think, yeah, my solution looks nothing like theirs, but I think it should be fine. Let me just see how it looks compared to theirs. Okay, so the first one is length 6, and then these are, so 6 over 2 is 3, and then these are length 3, yeah, by their definition. And then what do I have? I have 2, 4, 3, 5. So it does contain 0. It contains it in the first half. I think no, I think they should have the same endpoint. Yeah, I think I want to go all the way to at plus n over 2. Yeah, they want to end at the same place. Yeah, so it goes, and I do use their indexing, right? Yeah, it starts at 1. Okay. So it goes, so here it's 0, so that's 2, 3, 4, 5, so 1, 1, 1 after that. So that should be 2 plus 4 plus 8, so this is 12. But in the other one, we start at 3 and go to 5, so it's 1 plus 2 plus 4. Wait. Wait, is that divisible? Am I adding wrong? Oh, so it's 2 plus 4 plus 8. That's 14. I thought it was 12. And then the other one is 1 plus 2 plus 4, which is 7. Okay, so yeah, this one works. This next one. Okay, I noticed they don't test it on all 1s or all 0s. Oh, do I even test it on all 0s? I guess it sort of works on all 0s. Yeah, so this is the 0 in the first half case. So I guess literally all of them have a 0 in the first half. So maybe well, let me check 5 actually. So it's the fourth one, 1, 2, 3, 4. 1, 2, and 1, 3. So is 2 long enough? So yes, yeah, it needs to be at least half, but rounded down. And so this is length 2. Yeah, and those are just the same number, so of course it works. That's a 0 in the second half one, because it's not in the first half rounded down. So it works when there's 1 0 in the middle. Let's look at what it does for 6. For 6, I imagine should be 1 to, yeah, it just finds the first 0, goes 1 to 4, and then it goes 2 to 4. So those should work. 3, sort of a short one. 1, 1 is long enough because, yeah, we just need a string of length 1. So 1, 1 is totally fine. Yeah, I guess they don't like that one in their solution, but I think it should be satisfying, and they just find the same number. Okay, and let me just test it on all 1s to see if that works. Okay, and it finds 1s long enough, 1, 2, 2, 3. Yeah, if they're all 1s, yeah. My all 1 solution is sort of silly, but that should work as well. I guess I'll submit. There's no other conditions, right? All I need is that at least one is distinct, but not both, and I do that. And k can be 1, which I guess in my solution often will be. I guess in my solution k will always be 1 or 2, but that's fine. We round down. Okay. Yeah, I'm satisfied. I'll submit. It's a slow one. Wrong answer on pretest 1. Did I miss some condition? Maybe I misunderstood the problem somehow? Okay, so we get a binary string of 1s and 0s. And what is our goal? Our goal is the beginning of the first substring, end of the first substring. Yeah, so I'm printing out. And then if there's multiple, print any. Yeah, there's no condition on the length besides that it's at least half. We don't have to find the longest possible one or the largest possible k. Huh. Yeah, what's not working here? Maybe I can actually double check their test cases. So in the first test case, what do they find? They find the 4 1s and 101. So I guess that's sort of a nice one, but ours should be valid too. Huh. So they give us the length n and we read it in. Yeah, and so the first test case is like always their input, right? Do they not like my input on their test case? Strings are not divisible. Test case 4. Okay, so it doesn't think that they're divisible in 1, 2, 3, 4. Where I give 1, 2, 1, 3. So that's the fourth one. 1, 2, 3, 4. So 1, 2. Oh, am I reading backwards? I'm reading like right to left instead of left to right. Yeah, you're right, Scruffy. Yeah, yeah. Yeah, I was just thinking backwards. Okay, so 0 is in the first half. That's actually a leading 0. So I want to do something like this where oh, that's so annoying. So I want to start so I find the 0, I started at, and then I should just go to n. And then I should go to at plus 1 and go to n as n again. And now that's the leading 0. So these are like the same number. And now here this is the trailing 0 situation. So I want to find that trailing 0, and I know it's in the second half because of I've already checked the first half for zeros. And now I want to end at the same place, which should just be 1 in both cases. And then in the first one I include it, and the second one I don't. Wait, so is this actually just correct both ways? Wait. Okay, so now I get different number. No, I still give 1, 2, 1, 3. Wait. 1, 2, 1 to 3. Okay, so this is trailing 0. Wait. In this case, it's 1 plus 2, it's 3, and in this other case, it's 2 plus 4, it's 6. Oh, but I need to have them the right way around. I just need to switch these up. Right. So this should be the larger one, and this should be the smaller one. And in these ones, they're actually equivalent, so it doesn't matter. Okay, so 1, 3, 1, 2. Okay. Okay. Thanks for catching that, Scruffy. Yeah, I guess I just misunderstood divisibility. Okay, then, or how to read numbers. Okay, so then this one is obviously correct. This one also obviously correct. And then the divisibility one now works, though I guess all I did was really flip them. So like 1 includes the 0, 1 doesn't. I need the first one to include the 0 because that's the one that I want to be divisible by the other one. Right, that is the one I want to be divisible by the other one, right? Yeah. Okay, I guess I'll change something, so I'll resubmit. Yeah, it's sort of like a funny problem because normally I feel like the test cases give you some testing and you can have like sort of high confidence if you're right because of that, but in this case, like none of mine match theirs at all, so I just have to like run it in my head and understand the problem. Okay, it passed the pretest this time. Okay, sort of a embarrassing oversight, but it happens and we were able to correct pretty quickly. Okay, it looks like we're sort of keeping pace. I guess we were around 2,000 for this one, so we were sort of pulling ahead. Wow, the last 3 contests I've done, I've had this like D1, D2 structure, so maybe this time I'll actually get one. Looks like we're doing decently, so let's try to get 2 more. Maybe just 1 more. Okay, so this is an easy version. Okay, the easy version, we don't need to actually compute the numbers of the things, but I guess the bounds will be the same. Okay, so Stitch likes experimenting. Oh, is this like Lilo and Stitch? With his friend Sparky, and today they build another machine. Okay, so the main element of this machine are n rods arranged along one straight line and numbered from 1 to n inclusive. Each of these rods must carry an electric charge equal either to 1 or -1. Another condition for this machine to work is that the sign variable sum of the charge in all rods must be 0. Okay, equal number of minuses and 1s. Sparky charged all n rods with an electric current. Unfortunately, it happened that the rods were not charged correctly. Okay, we don't have 0 sum. The friends decided to leave only some of the rods in the machine. Sparky has Q questions. In the ith question, Sparky asks if the machine consisted only of rods from numbers Li to Ri inclusive, what minimal number of rods could be removed from the machine? Okay, so we only remove rods so that the sign variable sum of the charges on the remaining ones would be 0. And if it's already 0, we don't have to remove anything at all. Okay, wait, this is sort of an interesting problem. Okay, I can see how this one's going to be a lot easier than the next one. I think I already see how to do this one. So I guess we'll just go over the whole string and compute like the running sum. And then when we get a query, we can just like compute the difference between those things. And however positive or negative something is how many rods you'll have to remove. If there's like 5 more pluses than minuses, you're just gonna have to remove 5 pluses. Actually, finding the pluses might make the problem slightly more difficult, but I guess I'll just do this one first. So So yeah, I'll read in line, and I guess I should add this to my template. They always ask about this. Okay, so let's keep track of sum. I'll just call it S. So I guess it should be of length n plus 1. Okay, and then for I in range line, if S, or, well, I'll just, yeah, just for C in line, if C is minus, then S at, oh, I need to keep track of where I am. Oops. So I'll enumerate it. So if we're at a minus, then I'll just let this be minus of what it was before. I guess I want 0 to be 0, and I want to go all the way up to n. So S at I minus 1 equals S of I minus 1. And then otherwise I'll just add it. Okay, and then I need to read in my queries. Oh, so I guess we get 2 numbers. So this one will be the pluses and minuses, and then I get n q. Okay, and n and q can both be quite large, but q is going to be a linear time computation. Okay, and then let's read in the queries. So for I in range q, I need to read it in. Oh, oops. Where was it? So I guess it's like start, end. So the number of rods, the number of questions. The second line of each test case consists of a non-empty string. Okay, then Q, so L and R, okay. Okay, and then the answer is just going to be like the size of the difference. So the absolute value of the, yeah, I guess it's, yeah, I guess the way I've indexed it, I can just ask for S of R minus S of L. Okay, so they're going to give me LR, and R is going to be the larger one, right? Yeah. It doesn't really matter, I guess, which order I subtract them in, because I take the opposite value. I think this is just correct. I guess I should start thinking, oh, I guess it's not quite correct yet. Oh, why did I put range? Just enumerate line. List index, this assignment index out of range. Do we not get an n? Or we get n and q, the number of rods. So shouldn't I only go up to n minus 1? So I should this assignment index out of range. I don't know why that would be, because so I should run along the line which goes, just print out maybe that'll be enlightened. So it goes up to 14, but S is like slightly longer than, so it runs off the end and not the beginning. I mean, shouldn't this be like n plus 1? It's like 1 longer than the line, right? I don't know. I'll just decrease it by 1. Okay. Okay. Now I guess it. Maybe I should have tried to understand what was going wrong there. I felt like it was right. Okay, so let's see if we get the right output. We do not. Let's see the first one first. Okay, so in the first one, are we off in the same? No, we're not off consistently either. Okay. Wait, we can. Okay, so there's only one input for the first one, and so the total number of pluses is 3, 4, 5, 6, 7. Wait, why do we have to remove anything then if there's 7 pluses? Shouldn't it be 7, 7? Yeah, why is the answer 2 for this one? Maybe I should read the problem more carefully. Oh. Oh wow, I'm really dumb. I should have read this problem more carefully before I started. Oh hey, Dark here. Yeah, I can say some things about B. Scenes from memory. Yeah, so my first inclination was just to do a bunch of casework. So if there's like a composite number, like 1, 4, 6, 8, or 9 in your number, then you just print out that number and you'll be done. And then like there's not that many cases left. There's like numbers that have 2 2s, 2 3s, 2 5s, or 2 7s, and those pairs will be divisible by 11. And now there's numbers that only have 1, 2, 3, 5, and 7, and then there's like 35 and stuff like that. There's not that many things. But then I was like, actually, this is a lot of work. So what I ended up doing was I iterated through from 1 to 1,000, and I just picked the first number that was a sub number of the number given and was not prime. So that's how I would recommend doing it. Just iterate from 1 to wherever, and then just check if it's a sub number. But it's also possible to do with casework because there's not that many cases. Okay, but here I just have totally flubbed it because I've forgotten to alternate the sign, which actually changes everything. So, Or does it change everything? So what have we got here? So we've got... So I can keep track of like an alternating sum. So if I know the alternating sum up to sk, and then I know like the alternating sum here. So say I know this alternating sum and this alternating sum, what must the total alternating sum be? So if I know, I'll call it A for alternating. So if I know AK and AN, what does this one equal? So I guess so if I know these, how can I find the other one? Okay, so I guess there's two cases. So if k plus 1 is even, or I guess I'll say odd, because I'll just say we start with 1. So if it's odd, then what do we have? Then we have this should just equal the sum. There, I'm going to drop this notation and just have like the end point. So if it's odd, then this plus this should equal this. So this will be the difference. But if it's even, I think it'll be the sum. Yeah, because then, yeah, now we're starting from 1, or we're starting from like adding a negative, but yeah, when we go the other way, we like don't consider it a negative. We'll have the whole thing be equal to this minus this. So this should equal this minus this. Yes. Or yeah, so if this starts at an odd thing, then this minus this will equal this. Right. So we'll have this equals this minus this. Okay. So ak plus 1 up to n should equal... let me do it the other way around first. We'll have ak minus ak plus 1 to an equals an. So it'll just be the negative of this. It should be k. ak minus an. Okay. But how does this help us know how many to remove? Because every time we remove something... So if it was just the sum, whenever we remove something, it would like bring it up or down. But in this case, things might get a little more complicated. Yeah, so I notice these numbers are like quite small. They're always either 0, 1, or 2. And I wonder if that's like a general thing where like the right answer will always be that small. Maybe I should figure out how to do it without making it efficient for every query first. There's a problem. So, I wonder if it's like a parity thing. So like using this method, I can compute the alternating sum, or I can pre-compute it, and then I can now easily tell what the alternating sum for a subsequence will be with this like dynamic type thing. And then maybe it's just like a parity thing. Like maybe, so it could be 0 and then I don't have to remove anything. That's clear. It could be 1. If it's 1, If it's like equal to 1, mod. So another observation is the alternating sum of an even length string is always, or the alternating sum of an odd length string is never 0. So it has to be an even length string. So maybe if it's an even length string that isn't equal to 0, you can always just remove 2 things to get it there. And if it's odd, then you can always remove 1 thing. Yeah, I think probably you can just remove 1 thing. Yeah. So if it's odd length, and it has some sum, then there must be like some kind of bisecting thing. So like, so if I remove SI, what happens to the sum? Like removing that changes it by like 1 up or down, but then it like flips the whole thing. Everything over here becomes the negative of what it was. So I think there must be 1 that would flip it to 0. Because if like removing this flips it by too much, then I can remove the next one instead. Yeah, I think that'll work. And then if it's even, then of course we have to remove 2 things. And I think there'll always be 2 things we can remove. I think let's just code it up and see if we get their matching output. But I'm pretty sure that that'll be right actually. Okay, so now I want to compute the alternating sum. So if I equals, so if C equals 1, what should I do? I guess I should have like an XOR. And I'll just XOR with the parity of the index. So yeah, so whether it'll add or subtract for a minus flips at each step, and I get these alternating sums. And then when I want to compute L and R, I can just compute the current sum, which I think by my math is the same essentially, just like a flip. So I'll compute that. So then if cur equals 0, print 0. Otherwise, if cur is 1, or is 1 mod 2, then I can just remove 1 thing. Otherwise, I can print, or I'll have to remove 2 things. Wait, I thought this was XOR. I probably need parentheses. Okay, and now it's printing things out. Let's see if it agrees at all. This might just be wrong. Oh, is it like totally backwards of right? No, it's not totally backwards of right. Wait, so 2210 1121. Yeah, it's just totally wrong. Okay. Wait, I think. Oh, right. This should not depend on the difference. It should depend on the width. If L minus R, or R minus L. Yeah. So then it's, wait, that didn't change anything. Oh, +1. It's 221. Okay, so somehow I must not be computing if we're already done correctly. So this line must be wrong. Hmm. Okay, so the zeros are incorrect, but I think everywhere where we don't get an incorrect 0, it's correct. So I think it is just depending on the parity, and I just need to like do the other thing correctly, and then it'll be right. So somehow this cur is just nonsense. Let's double check our math. So how can I know? Oh, well, it's also possible there's an off by 1 thing going on, but no, I think I should have gotten that right. Yeah. Okay, so I compute, what am I computing? I'm computing the signed, or I'm computing the alternating sum. Let me just print out S to see if it makes sense, because that might be wrong. Let's see, so where's S? Okay, so for the first one, what is it? Okay, so it starts at 0, and then it, so it's sort of backwards of what I expect, but I think it's right, except for going backwards, so maybe I'll just switch it though to make it more intuitive. So make this plus. It shouldn't change the behavior at all, but make it easier to read. Okay, so what is it doing? So plus is positive, up. Now it's an alternating sum, so the minus is also positive, so it goes up again, and then it goes down. Wait, so it goes up, up, down, down, up. Wait, is this right? Okay, it's hard to read. So the first plus makes it go up, the second minus makes it go up, the third minus makes it go down, the fourth plus makes it go down, yeah. The fifth plus makes it go up, the sixth minus makes it go up, the seventh minus makes it go down, the eighth minus makes it go back up. Okay, so it seems to be working. Yeah, it seems to be working. But so how I'm going from this to this must be wrong then. So let's just double check the math. So I'm getting in R and L, and okay, so yeah, so we've got S1. Okay, so we've got S1 up to SL minus 1, and we have SL up to SR, and we want to determine whether this is already done. And what do we know? We know the alternating sum ending in each of these indices. So A1 up to AL minus 1, up to AL, up to AR. Okay. So how should these things relate? So so we should have so the signed sum of this will either, when we add the signed sum of this to the signed sum of this, we either need to add or subtract the signed sum of this from this to get this. Yeah, one of those will be right. So that means if we subtract this, okay, I think it's actually just we need an L minus 1. We'll see. 2210. Wait, that actually looks right. 2210. 1121. Okay, so they actually only give us 1 where it's actually 0. So maybe we should make our own test cases to see. We just get rid of this print statement. Yeah, let's make a test case with, say, 10. I'll just give it 4 queries. So yeah, let's just say it's all pluses. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, let's ask about 1 to 10. 0. Okay, so if I give it any even length thing, the answer should be 0. Which is maybe not that interesting. Maybe I should do a different test case. This one has to remove 1, yeah. Okay, maybe this isn't the most interesting. But maybe they're all sort of like that. I'll give 1 more. Plus plus minus minus plus plus minus minus plus plus minus. Okay. Oh, I didn't even count. Okay. Plus plus minus minus. 1 too many. Alright, let's see. 1, 2 shouldn't remove anything. 1, 4 shouldn't remove anything. 1, 6. Oh yeah, and then like I guess 2, 7 shouldn't remove anything. Or no, does 2, 7 have to remove anything? What is 2, 7? I should have made a slightly smaller one to make it easier to reason about. Or maybe there isn't a smaller one that captures all this. What does it go? It goes plus, 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 minus, minus, plus. Oh yeah, so they all alternate. Like when I go from one to the other, both the index changes and the sign changes. So it'll always be plus 2, minus 2. So yeah, so when it's like this, it's like adding 0 together 3 times. So when it's like this, it's adding like 2 together 3 times. It goes like, so. So if I did not 2, 7, but like 2, 5, that'd be 0. Okay, I think this is right. Oh, hey, Pseudomaze, how's it going? Thanks for tuning in. This is D. Nice dinosaur, by the way. Okay, looks like it's right. It's going through these pre-tests awfully fast. If you're wondering why I got this one wrong, it's because I had my wrong endianness. I was like doing it, my numbers little endian instead of big endian. It's sort of annoying. I'm doing pretty well. You can't wait to leave academia? Nice. I mean, so what are you up to? Are you like doing a PhD, or are you an undergrad? Or I forget. I feel like we talked about this before. You sent me that weird GPT-3 thing, right? Or not GPT-3, but like where you could like see merges of faces and stuff. Yeah, I actually have decided to leave academia. I'm taking a job. Oh right, Masters in Deep Learning. Oh yeah, you recommended I read that book about convex optimization. Yeah, I decided just to leave actually. I'm taking a job at this company called Maven, which does a I don't know, they run Sports Illustrated. It's like web development. I'm actually kind of excited to learn more about it. It seems like a lot of fun, and I think I'll be happier there than here. So that's part of the reason I have more time to do these contests. Though I don't know, in theory I guess this is almost interview prep, which I guess I don't need since I have the job, but I enjoy it a lot. I think it's pretty fun to do these problems. Let's see how we're doing in the standings. Oh, nice, not too bad. Actually, I wanted to see how people were doing the problems. Okay, so we've consistently been around 1,000, which maybe isn't great. Okay, so now we actually need to find the index we would need to remove to get it to work. So yeah, that certainly seems like a lot more work than the easy version, which is quite easy. Yeah, I've heard LeetCode is good. I've actually never used LeetCode. I imagine it's very similar to Codeforces, right? I guess it's like less like gamified and competitive and more like actually asking the questions that are most likely to be asked to you in an interview. So maybe it's more valuable. I've never used it though. Okay, so we've got an alternating sum, and we want to see which bits we'd have to remove to get it to be correct. I wonder if we can use like binary search. Or I guess there's like two cases. There's the case where it's odd and the case where it's even, and maybe they're quite different. Oh, maybe it's actually simpler than that. Maybe it's just like, yeah, maybe it just always. Maybe it only depends on the value. Oh, that's cool that it gives multiple solutions. But that's actually the beauty of Codeforces. Well, I guess we can't do it now, but like, you can just like go and see like everyone's solutions and just read them. I should do this more. I feel like I learn things about language features when I look at how people are actually doing the problems. But I'm sure it's actually better to see like professionally curated solutions and not just like whoever's fastest, because probably whoever's fastest is also most illegible. Oh wait, don't look at my. Wait. Oh, yeah, I've been hacking on the Fitbit. I guess I've always found like the memory and complexity stuff very intuitive. Like it just seems like you read it off the code. Like you just count the for loops and that'll tell you whether it's linear or quadratic. I guess there's more to it than that, and sometimes it's not super obvious, but I've never thought that was the hard part. That's interesting. Yeah, I guess not everything that's linear is equally fast. I wonder if, like, during an interview, I basically never talk about efficiency outside of like big O. I'm just like, oh, it's fine. Actually, that's not true. Very often, I will say things like, oh, string concatenation isn't. I can't just assume it's constant time and stuff like that. So maybe it's good to be aware of the subtleties. Okay. So if we've got some bits, or if we've got some partial, we have some bits. So if I cut off the last bit, it'll always change the answer by 1. But actually the same thing happens if I cut off the first bit. But I guess it'll like negate it and change it by 1. So we So we can do some like binary search thing, but that's like the most we can do. We certainly can't do like a linear scan to find out what to actually cut. So what happens if I cut at index I? So let's say I know the partial sums from A1 to AN, and I cut at I. So I guess these are the partial sums above these rods S1 to SK. Why am I using S for sine? Okay, so if I cut at A, I'll say if I remove the k, or I remove I, to be precise. Then what happens to the sum? So the new sum should equal the sum up to a minus 1 yeah, up to a minus 1, and then it should be, oh yeah, I guess whatever the sum was from an to ai plus 1, but subtracted instead of added, because I've switched its index, so it should be like minus a I plus 1 to n. Oh, I misspelled new. That's the new sum. Okay, and then this, I already knew what it was from the previous problem, but I guess there's some like parity thing? Maybe. Or actually, it should probably just always be this. Or, no, I guess it depends. So I guess it should be ai minus 1 minus ai plus an, or ai minus 1 plus ai. Or should it ever be plus ai? Somehow that seems like it. No, it should sometimes. Yeah, minus an. And so I guess it'll be, or I guess we always end up shifting. Maybe it's just always this. I'm wondering if it depends on the parity of I, like if one is the I is even case and the other is the I is odd case. But I'm starting to think it shouldn't be. Okay. So So what to do then? I guess somehow I need to like find the index I that'll make this land on 0, like that'll make this equal to this. Actually seems a little tricky. I wonder, I'm just going to read the next two problems to like decide whether I'm working on the right problem. Just real quick. So let's read E. Rescue Niven. Okay, so after crossing the windswept wastes, Ori has finally reached the wind-torn ruins to find the heart of the forest, or the ancient repository containing this priceless willow light design. Wow, there's a lot of, okay. They're very fond of string expansion and increasing subsequences. Me too. So suppose we have a string S1 to Sn, then its expansion is defined as the sequence of strings S1, S1, S2, dot, 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 S1, Sn? Okay. And then the same thing starting at the second index. Wait, is its expansion just every substring in order? In dictionary order by index, I guess? That is what it is. Yeah, okay. Oh yeah, so it goes A, B, A, B, C, A, B, C, D, B. Okay. To open the ancient repository, Ori must find the size of the largest increasing subsequence of the expansion of the string S. Wait. Shouldn't the largest... Oh. Oh, that's interesting. Okay, okay. So, in... Yeah, I was thinking these things should be the same, but now we're not comparing characters to find whether it's an increasing subsequence. We're comparing strings. So in this case, I guess the largest one should be A. I think it should be 4, and like there's a lot of ways to achieve it with A, B, A, B, C, A, B, C, D, or A, B, C, D. Wait, no. There's long. No. The whole thing is just an increasing sequence. Yeah. Yeah. A string is lexicographically smaller than a string. Okay, it just defines what the dictionary does. And then n should be up to 5,000, so we can do something quadratic, sort of. Probably better to be linear if we can. So my first observation is that if you have a alphabetically in order string, then its expansion is also alphabetically in order. I wonder if the answer is just you find the longest increasing subsequence and then you just choose, like, print out and choose 2 for that. Or let's see, this third one's 12, so it goes 1, 2, 3, 4, 5, 6, 7. Oh, okay, so I think if the yeah, I guess there's like a wrench in this thinking about like characters being not unique. Yeah. So the fact that characters are appearing more than once, I think, makes things like a little more complicated than I was hoping. Uh, hmm. And we want it to be strictly increasing, right? Yeah, I guess if we didn't want it to be strictly increasing here, we could do... I guess we couldn't do slightly more here. I mean, so how do we achieve 9 for Akbak? So is it like a... oh yeah, imagine it's like A, B, A, C. I guess there's a question of whether I want to use... Okay, I guess they explain it here. So we get... The answer can be A, C... Oh, right, A, C, B. Or, yeah, because we'll just... Yeah, for the first one, we might as well just include everything. And then we skip the C... Yeah, okay, so I guess a word is always ahead of its prefix. So N is always achievable. Like you can always just take the first character, the first 2 characters, the first 3. And then if the second character comes after the first character, you can always take everything that follows it as well. Yeah, I wonder if that's just how it goes. And then there's sort of like like at each character there's like a choice of whether you include it, and you can choose wrong. So if you like choose C and then take everything that follows it, you can no longer choose B because B comes before C. So maybe it's like just a dynamic programming thing where you just go over and we say, okay, what would happen if we took C? If we took C, then in the future we have to start after C. We have to start at least D. Yeah, and then, but then we get some amount, and then yeah, I guess it's just like a DP thing where we keep track of the starting characters and add things up. I think that actually works. Seems not too complicated, so I guess I'll just code it up and hope we're right. So this is E. Seems easier than the second part to me. Okay, so what do we take in N? Yeah, I need to add this to my template. Like every problem has an N, almost. And then I'll just read in the line. And some int. Okay, so there's like 26 starts. Okay. So for C in line, wait, so is A is ahead of A, right? False. Wait. Okay. So just keep track of score. So score will just be a dictionary, and in the beginning, this will just map to 0, no points. And then for C in line, for character in line, for possible score, for S in score.keys, we have the option to take it or not take it. So I'll just say score at C can now equal the maximum of the previous score if we choose to take it. Oh, and I need to know our index. I'm working in sports analytics? No, I'm working for the company that owns Sports Illustrated. I have been doing some sports analytics on the side though. I can show you a spreadsheet I made to predict the probability that Caruana wins the Cinquefelds Cup. Seems like he's about 15% to do so to me, but no, I haven't done that much work in it. Yeah, like I've been playing on Polymarket a little bit. It's been fun, though it's sort of been buggy today. Yeah, that's the website. Yeah, it seems like that should be like a units website, right? But yeah, it seems like it'll be fun. Thanks. Okay, so I'll take the maximum of this or the new score. Oh, so I can only add it if it's greater. So if C is greater than S, then my score at C should be the maximum of the previous score I was achieving or the new score I could achieve, which is the score for S plus appending everything, which is N minus I plus 1. And then answer equals 0 for CS in score.items. Answer equals the maximum of answer in S. There's only 26. There can be at most 26 things in score at any one time because, of course, there's only 26 letters. I could use an array instead of a dictionary, but why think about indexing? Oh yeah, I need to use Control D instead. Scruffy was telling me that. So this is E. Oh. See if it's true. Key error A. So for S and scored. Just use the default value. 0. Dictionary changes size during iteration. Right. Let's just say next. Next is a new dictionary. And at the end, score equals next. And then I'll update next. Doesn't like that. Why is that not good? So I'm currently at so I iterate through my line and I get all these characters, and then I look through the previous characters and they should all be greater than A, right? Maybe they're all less than A? Quick check. Okay, it does update sometimes. So score at S should start at 0, but then I add n minus I plus 1. Let's just print out next. So it's not always empty, but often. Oh, I need to. I should just propagate to the next one. So if C is greater than S, yeah, everything that was achievable is still achievable. So I should just add it. So I'll just say next at C equals score at S. Or next at S equals score at S. No, it's off. All right, let's see what I'm printing out. 11, 17, 13. Seems like it's roughly right. Let's see. Is my algorithm just wrong? So am I always off in the same direction? No, sometimes an overestimate, sometimes an underestimate. So I must. There's something else going on. Let me just print score out at the top of the loop. So yeah, let's see how score is being updated. So if I take nothing, I'm 0. Oh, okay. Wait, this shouldn't be 6. This should be 5. It should be. Wait, n is 5. Oh, right. It's 1 indexing. This would be like if I was indexing from 1. Yeah. Okay. Now let's see what it looks like. 9, 15. So it's actually right for the first one. So I'll skip it. And oh, now am I always in 9, 15, 12, 29, 8. So now I'm always an underestimate, which makes me think my algorithm might just be wrong. So I'm always an underestimate. And let's see one where we're wrong, which is the second one. All cops are bad. All cops bad are. am I wrong about? No, I'm right about that one. I want to look at the smallest one I'm right about or wrong about, which I guess is Sparky. Okay, so what can I do? I can take. So I can take the S and I get to 6. Or I can not take the S and take the P and get to 5. Or I can not take the S or the P, I can take the A, get to 4. And now there's this thing about R. Sparky. So I think I'm just taking the max with the wrong thing. Oh yeah, because I could have like already filled it in. Yeah, so I get to A, or I get to R, and now I can I can like wait, so R comes after S. A, B, C, D, Q, R, S. No, R comes before S. It's a hard problem. But in any case, no, I guess 8 is right. Because if you take the R, the best you can do is take the P first, and then add RKY. So it's 5 plus 3, so I get 8, which is correct. A stays at 4, P stays at 5. Okay, so actually, maybe that's just right so far. And I get to K. So if I want to take the K, the best I could have done before is take the A. So it's 4 plus 2, so it's 6. And then everything else stays the same. And then I get to Y. Okay, so Y should append to the R. So, because R is before Y. Okay, so this shouldn't be score.getC, it should be next.getC? Or so I iterate over the previous keys, and if they come after which Y does, so Y comes after R, then I should set it equal to so I'm iterating over the previous keys, and I consider taking it, and I consider if I was already in it, but I guess I could have already found something better. So instead of maxing here, I should max with score C as well. Yeah. Yeah, I could have already filled it in. Then I would update it. Max probably takes more than one argument. I probably don't need that. Yeah, what am I doing? Key error A. Oh, right, just get. Nine, 3, 9, is it all right? 9, 15? No, I don't think that's right. 9, 12, not there. 9, 17, 12, 29. Well, we fixed one test case, so progress. Let's see what's wrong with this this next one. How much time do we have, by the way? Okay, we can maybe figure it out. Okay, so this next one is all A's. Wait, no, this one. We get the all A's one right. So it's Akabaka. Okay, so we can take this first A, and if we do take this, maybe my algorithm is just wrong actually. Now that I think about it, because there's some incentive to skip the C. I thought there'd be no reason to skip, but I guess there is, because once you take the C, you can no longer take like AB. Yeah, so picking up the C precludes you from. I should have thought more before I started coding. This is, I guess, more difficult than I thought. Yeah, I thought one could be quite greedy and just once you take a first character, take all the future characters, but it actually is removing future options. Yeah, and I was no. Why is that the case though? Because it sort of seems like you might want to take like the whole prefixes like AB, ABA, ABAC, BA, but that's just like less length than taking AC, ACA. But I guess if you skip, uh, if you skip AC and just take the A, and then when you get to AB, oh, I see, because you skip AC and then like the AB, like all that stuff is one less length, which feels bad. But then because you took this one instead of this one, you also get to take ACBA at the end. Yeah. I was a little too greedy there. Huh. Probably need to keep track of a little more state then. How to do that? So instead of just keeping track of A, I might want to also keep track of like the prefix. Huh. Yeah, I feel like, yeah, if we track the whole prefix instead of just the first character, maybe we'll be getting somewhere. But I worry that the number of possible prefixes is quite large, but I guess maybe we only have to track the ones that aren't shadowed by other things. Yeah, so if we have some like string and it's like a prefix, we probably don't need to care about strings that are both later in the word and later alphabetically. That's probably like dominated. Yeah, I don't think I'm going to get it in the last 5 minutes. It's sort of unfortunate. Yeah, I tricked myself into thinking this was working. Maybe I'll read the last problem. Maybe it'll be secretly very easy. Probably not. Yeah, maybe we should have thought about this one. I guess it does look like it's a little bit easier. Though people tend to do them in order, so I don't know. I do think there's some kind of like binary search or simple formula to find an index that you could remove. D1 itself was very easy once you observed the pattern. Tubular bells. Do I know what tubular bells are? I do not. They are musical instruments made up of cylindrical metal tubes in an orchestra. They sound like bells. That makes sense. Okay. Mike also has them. So he has N tubes. Each of the tubes has a length that can be expressed by an integer from L to R. They all have unique lengths. and their total length. Wait, what is this? Their lengths exist. There's n different possible lengths. Okay, so okay. So yeah, Mike's tubes are a permutation of n, or a permutation of the letters from L to R. And then we must figure out the permutation. But he won't tell us L or R. He will only tell us n and then allow us 5,000 queries. Oh. Okay, and then for each query, I can name 2 positive integers. And then he will give us the least common multiple of the values at those 2 integers. Interesting. Okay, so he gives us 5,000 queries. And n is at most, or r is at most 2 times 10 to the 5th. Wait, how can we possibly have enough information to solve this problem? Tubular bells? Yeah. That's a real velociraptor emoji for sure. Should you Google that? Yeah, who's organizing this contest? They must love their bells. Wait, so in all of our queries, we only get information about at most 10,000 bells, right? But there could be as many as 100,000? Wait, what is 10 to the 5th? Oh, no, we can ask n plus 5,000 queries. Oh, okay, we have more than enough information. Or we should have more than enough information, but I guess it's like occluded. We only get like the LCM. I guess we probably... So do we need to find L and R? Oh no, we need to determine the permutation entirely. Oh, okay. That's interesting. Wait, Mike Oldfield has a song called Tubular Bells? Are tubular bells a real thing, though? Oh, I need to watch The Exorcist. I've actually never seen it. I haven't seen like any of the classic horror movies. I've heard that they're not that fun to watch today because I guess special effects are way better. But I feel like I should have seen at least The Exorcist. Yeah, I guess I'm not gonna get E or F. Let's see how we finished though. Not the worst if we hold up. Better than 1,000. I think all of our submissions will hold up. I guess that one wrong submission probably hurt us a fair bit. Sort of an embarrassing oversight. It's like annoying when the problem statement doesn't really give you any real test cases because I don't know. Because every answer is going to be unique. But yeah, it was a fun contest. Yeah, I really got to eat. I haven't eaten anything all day. But it was fun to do. And thanks everyone for watching. It's a fun stream.